Okay, so the last big idea would be, how does motion, right, particle motion, have to do with this? So if we talk about displacement, right, displacement is basically saying, like, if here I am at time equals 0, I am, let's say this is 0, and this is 5 miles from my house. Okay, 5 miles. And now I keep on moving, okay, and I wind up here. Let's say this is at t equals 3. I wind up to be, I don't know, let's say I wind up to be, I don't know, 32 miles from my house. And then I keep on coming back, right? And then at t equals 4, I wind up being, I don't know, 25 miles from my house. Well, what's my displacement? My displacement is really just my net change, right? My displacement is just this change in distance. So my displacement is 20. And the way that you find displacement, okay, is you integrate velocity. If you integrate velocity, you find, well, if you integrate velocity, you find position, right? So if you integrate velocity from A to B, you get the position at B minus the position at A, which in this case, I mean, the position at B right here is this, 25, and the position at A is this, 5, right? Position at A, time equals 0, time equals 4. So really what you get is 20. You just subtract the difference in the position. That's displacement. So let's try to figure out displacement here, and I will leave that top diagram. So your displacement from 1 to 5 is going to be, really, your velocity needs to be integrated. And if you integrate velocity, what are you going to get? Well, what velocity is the derivative of what? Position. So if you integrate velocity from 1 to 5, you will get not velocity at 5 minus velocity at 1. You'll get position at 5 minus position at 1. And that's your net change in position. That's your net change in position. That's your displacement. That's how far you moved. So the integral of velocity, well, in this case, it's going to be t to the 4th over 4 minus 10 t to the 3rd over 3 plus 29, whoops, 29, not my best, t squared over 2 minus 20t, and we're going to go from 1 to 5. I'm assuming that you can plug that in and get that. This is in your book if you want to take a look and see if you get the right answer, but we're just doing basic algebra at this point. Now, total distance traveled, a lot trickier. And you can obviously punch this, just integrate this from 1 to 5 in your calculator as well to just kind of see. Now, total distance traveled is going to be tougher. Okay, so displacement is this green thing here. Okay, so we got that. Total distance traveled is more work, unfortunately. So total distance traveled is basically saying, like, okay, well, if I started here and I go like 10, let's say, so this is 10 units, then I go back 3 units, and then I go this way like, I don't know, 8 units. Well, what's my total distance traveled? Well, I have to add all these different distances up. So I've got to find all sorts of different displacements. I really have to find when the particle is stopped. So I have to find when this thing, the velocity, is equal to 0. Because that's when the object stops, and it might turn around at those times. And that would be a concern if it turned around. As far as breaking this down, I don't have a fantastic way of doing this aside from like the rational root theorem. So I'm just really hoping that like 1 is an answer to this. So let's just see if 1 happens to be an answer. Sometimes the calculus book does stuff like this. So it's 1 minus 10 plus 29 minus 20. And yeah, that works out. So sometimes they just want you to use a little common sense to realize that t equals 1 is a time when this thing stops. If you plug in 1, it's going to work out. So once we have t equals 1, that's one of our times that we have no velocity, it stops. When's another time? Well, we kind of need to like factor this t equals 1 out, so what I'm going to do is I'm going to long divide by t plus 1, or t minus 1, sorry. This could be a review for you, so you might want to take a look at this because long division is going to be an important thing for some integration stuff. So t to the third multiplying, so we get t squared. We're subtracting in this case, so we have negative 9t squared plus 29t. That means that we have negative 9 here, so we have negative 9t plus 9. This is squared, sorry, so this is going to be 9t. So I messed that up a little bit. So subtracting, so I have, let's see, I have 20t. So that's going to be plus 20. And that'll be 20t minus 20 because I'm bringing this down. And so I have 20t minus 20, and it goes in evenly. So it looks like what I have still is t squared minus 9t plus 20. That's my other factor. We know that t minus 1 is a factor, and this is equal to 0. I'm going to erase this so you can always rewind if you need to see that long division again, but I need to give us a little space, and I don't want to make this video too long, so it's up to you if you want to see that again. By all means, do a little long division. So what I'm saying is that this has been broken down now, so t minus 1, and we can break this down into t minus 4 and t minus 5 by factoring. So we have different times that this object's going to stop. It's going to stop at 4 and it's going to stop at 5. What does this all mean? Well, what this means is that these times are what you're going to have to pay attention to when you integrate this. You're going to have to, unfortunately, integrate this from 1 to 4, and then you're going to have to integrate it from 4 to 5. Why? Because, well, first of all, luckily these are the endpoints of the interval, so these don't really break our problem up much more. But the object stops at time 4, and it turns around, so I need to figure out the displacements and add them up. So it's kind of like A, but you got to break it into parts. So I'm going to integrate velocity over that time, and I'm going to integrate velocity over that time. Okay. Now there's one thing that you have to keep in mind. If we're talking about total distance, if this comes out negative, I need a positive distance. If this comes out negative, I need a positive distance. Those reds are absolute values. With a calculator, there are some better ways of doing this, and we will talk about that in the future. But for now, doing it by hand, this is how we get it to be. So dt should be here, by the way. So hopefully that makes sense. I'm not going to do that math out because you can do the integrals yourself. Don't forget about absolute value because distance is always positive. And at that point, you're trying this problem. So, you know, it might be a little bit of work. Use your calculator to verify. And that's really all I have for this video, I believe. Yep, don't pay attention to that. Okay, we'll talk to you soon.